Lesson 80, Operations with Scientific Notation. First, a review of scientific notation. When we want to write very large and very small numbers, it's useful to use scientific notation. Remember that to write a number using scientific notation, we're going to move the decimal point until there's only one digit to the left of it, and then we'll multiply that number by 10 raised to some power, and this will make up for the fact that we moved the decimal point so that the value of it still stays the same. If we started with a large number, larger than 10, we're going to end up with a positive power on that 10, and if we started with a number smaller than 10, we'll end up with a negative value. So as an example, 4 million, we can write as 4 times 10 to the 6th because we move that decimal point 1, 2, 3, 4, 5, 6 places, and this is larger than 10, so it's a positive power there on that 10. Similarly, this number we can rewrite as 7.1 times 10 to the negative 8. It's smaller than 10, so we know we're going to need a negative exponent on that 10. And when we move the decimal point over 1, 2, 3, 4, 5, 6, 7, 8 places, that tells us that it's going to have to be a negative 8 as that power there. And again, notice that I moved the decimal point only until I had just a single digit to the left there. It's still fine to have other digits after the decimal point, but there should only be one in front of it. All right, how do we multiply two numbers using scientific notation if we want to multiply two very large or very small numbers? First, we'll convert them both to scientific notation. Then we're actually going to rearrange to put the powers of 10 next to each other. I'll show you this in a second. We'll multiply. This will make it easy to combine the powers of 10. And at the end, make sure your answer is in proper scientific notation. So if we want to multiply 40 million by 200,000, we can convert them both to scientific notation. So 40 million becomes 4 times 10 to the 7th, and 200,000 becomes 2 times 10 to the 5th. Now notice I've left these parentheses here to make it easier to see where each of these came from. 40 million, 4 times 10 to the 7th, 200,000, 2 times 10 to the 5th. But since all of our operations here are multiplication, it doesn't matter what order we do them in. So we're actually going to rearrange them. 4 times 2 times 10 to the 7th times 10 to the 5th. This will make it a little bit easier to see what we're going to do. We're going to multiply together the 4 and the 2 and get 8. And 10 to the 7th times 10 to the 5th multiplied together. Since the bases are the same, we add the exponents and we get 10 to the 12th. That is proper scientific notation. There's only one digit to the left of the decimal point. What about another example? A small number and a larger number. So first with this number over here on the left, it looks like it might be scientific notation, but it isn't because we don't have anything to the left of the decimal point. 0 doesn't count there. So we're going to need to convert this to scientific notation, leaving in the 10 to the negative 4th, and then we're also going to need to convert 70,000 to scientific notation. So this will move the decimal point over 1, 2, 3, 4, 5 places, and that's a small number, so it becomes 4 times 10 to the negative 5th. We're leaving in the times 10 to the negative 4th. We didn't do anything to that. And then 70,000 becomes 7 times 10 to the 4th. Again, this is all multiplication here, even though there's no multiplication sign written there. 2 parentheses next to each other tells us multiplication. So we can rearrange the order here. 4 times 7 times 10 to the negative 5th times 10 to the negative 4th times 10 to the 4th becomes 28 times 10 to the negative 5th because we add them together. Negative 5 plus negative 4 gives us negative 9. Plus 4 gives us negative 5 again. Now, once you get this, be careful. This is not your completed answer yet because 28, that has 2 digits to the left of the decimal point. That's not scientific notation. So we need to take the 28 and convert it to 2.8 times 10 to the 1st, and that's still going to be multiplied by 10 to the negative 5th. We can combine these by adding the exponents. 1 plus negative 5 gives us negative 4. So our final answer is 2.8 times 10 to the negative 4th. What if we want to divide two very large or very small numbers? Again, we'll convert them to scientific notation. Here it's going to be most helpful to write it as a fraction. That'll let us easily figure out where we've got powers of 10 to combine and where we have other things to combine. Remember that when we divide things with the same base, the exponents subtract. And again, make sure your answer is from proper scientific notation. So if we have 600 million divided by 30 million, 600 million we can rewrite as 6 times 10 to the 8th, 30 million 3 times 10 to the 7th. I'm going to rewrite that as a fraction, 6 times 10 to the 8th over 3 times 10 to the 7th. It's easy to see here where we can divide. Now remember, we're allowed to divide these out separately because here the 6 and the 10 to the 10 to the 8th are combined by multiplication. And so since this is division here, we're allowed to undo multiplication using division. So we can do 6 divided by 3 gives us 2. 10 to the 7th divided, 10 to the 8th divided by 10 to the 7th gives us 10 to the 1st. And that's good as it is. What about 0.00012 divided by 4,000? So that first number will become 1.2 times 10 to the negative 4th. 1, 2, 3, 4. Divided by 4 times 10 to the 3rd. Rewriting as a fraction will be helpful here. So we need to do 1.2 divided by 4. We'll get 0.4 there. And 10 to the negative 4th divided by 10 to the 3rd, we subtract, so negative 4 minus 3 gives us 10 to the negative 7th. Be careful, we need to fix this here because we don't have anything to the left of the decimal. So 0.4 we can rewrite as 4 times 10 to the negative 1, multiplied by 10 to the negative 7, and so it'll be 4 times 10 to the negative 8, those combined. Let's look at some that are a bit more complicated using both multiplication and division. Here, we're going to actually separate out the parts of the number that are 10 as a base with an exponent and the parts that aren't. And again, making sure that our answer is in scientific notation. So here we have 0.07 times 10 squared times 800,000 over 10,000 times 0.000004. We'll rewrite each of those using scientific notation. Now this 0.07 times 10 to the negative 2, we got to rewrite that. We'll have 7 times 10 to the negative 2 from that, times 10 squared. 800,000 becomes 8 times 10 to the 5th. 10,000, 1 times 10 to the 4th, and this number becomes 4 times 10 to the negative 7th. Now notice again, on the top and on the bottom, these are all being combined by multiplication. There's just the division between them. So we can rewrite this as two fractions, again with multiplication going all the way across and all the way across the bottom. Remember that when we multiply two fractions, we multiply across the top and multiply across the bottom. So this is the same thing that we had here, just arranged in a more convenient format. Then we'll simplify each of these. So 7 times 8 over 1 times 4 becomes 28 over 4. And these three, 10 to the negative 2, 10 squared, and 10 to the 5th, add together to give us 10 to the 5th, or the exponents rather add together to give us that. And then 10 to the 4th times 10 to the negative 7th will give us 10 to the negative 3. We simplify each of these fractions. 28 over 4 is 7. And 10 to the 5th divided by 10 to the negative 3 is 10 to the 8, because we subtract 5 minus negative 3, or 5 plus 3, will give us 8 there. Last example, 0.08 times 10 to the 7th times 900,000 over 20,000 times 0.000003. 0.08 becomes 8 times 10 to the negative 2, again times 10 to the 7th. We get 9 times 10 to the 5th here, 2 times 10 to the 4th, and 3 times 10 to the negative 6th. Move all of our non-10s over to a fraction on the left, leave all of our 10s there on the right. Simplify, we get 72 over 6, and then these combine to 10 to the 10, negative 2 plus 7 plus 5 will give us 10. And on the bottom, 4 plus negative 6, adding those exponents, will give us negative 2. And we end up with 12 times 10 to the 12. 10 minus negative 2 gives us 12. Not done, because we have 2 digits to the left of the decimal. So we rewrite that as 1.2 times 10 to the 1st times 10 to the 12th. Combine those powers of 10, 1.2 times 10 to the 13th.